Hello everybody, my name is Pixel Rain, or Rain for short, and today we're going to be going over my contouring method. I know, it's it's been promised for a while, but we're here now. I will say the method is a bit of amalgamation of other methods rolled into one. It works by contouring all four corners of each quad face, taking our little Minecraft mesh and turning it into something that looks more like marching cubes for the moment. Now, normally that technique wouldn't be super efficient because it is reprocessing some points of data. So, for instance, if we're processing this corner right here in between these cells, let me go over to scene. So if we're processing this corner, it is getting processed for this face, this face, this face, and this face. Normally you would be like, well, that's bad though, because you're wasting the processing on it. But when you consider actual dual contouring, you're running the method over every cell inside your 16, 128, 16, or whatever size chunk or quadtree or octree you're doing it in. And you're processing all the error as well to find those corners. So it is less efficient, but not to such an extent that I would say it's not worth using. So let's get on with it. I am trying a slightly different method today for recording. Hopefully it flows a little bit more smoothly. I know the last video was painful to record and it wasn't the best to watch, I'm sure. So the first thing we're going to do is we're going to open up our voxel values.compute, our arrays for our mesh generation here. And at the bottom, we're going to add two new arrays. Get those fixed in line. The first array here is called axis. This is just the standard array, except for each corner of the vertice, we want to check in the direction that's not our local cell. So this is going to be the bottom back left corner, 0, 0, 0, in other words. And then this is the right corner, so 1, 0, 0. So you can see I'm just checking against the positive side of that axis. Down here in cell centers by axis, this is pretty much going to be the same check that dual contouring will use during its process. So for each axis, 1, 2, 3, we'll check 4 cells adjacent to whatever cell we find in axis, and then we'll solve for that. So we're going to head over into our voxel compute itself, and we're going to add a new struct up here called shared vert. This is just kind of to hold whether or not we've set that index within this block or not. So out of the 8, it's used specifically for shared vertices, not so much in our low poly rendering mode, but then we're going to come down to just at the end of our buffers here. Actually, I'm going to put it in the middle. And we're going to add a normal buffer because we are going to be calculating our normals now. And we're also going to, last but not least, add in 2 new booleans, one for use textures, because we are going to be adding texturing to this, and one for shared vertices, just so you can toggle it on and off. I will say now that texturing with shared vertices does not work as well, because the UVs are incorrect. What can you do? You're sharing the 8 vertices between all the faces. The vertices won't always line up. And then we're going to head on down just a little ways, and we're going to add in a new helper function. And this will be to convert that second array we added in voxel values, cell centers by axis, all these negatives to positives, just like our axis array up here. So if we're on a positive corner, we'll change that axis. So if we're on that bottom right corner, we'll change this to a 1. As you can see here, pretty simple code, just so we're always calculating to the correct axis for that corner. Now we're going to get to our actual contouring method, and for the most part this is pretty cleaned up. It's still kind of messy, but it works. I'm gonna keep it this way for the moment. So we have our block chord, the index in the array essentially that's coming in, the out for the position, out for the normal. So these will go back into our main method. Our actual vertex position within the block, and then our IDX or the index within said block. Then we have our 3 cached voxels, because we will only be touching 3 for each for loop iteration. The calculated density, this is only half used right now. The positions for our adjacent cell, which is used for that cell center access check, and then our adjacent cell root, which is our position plus that cell center plus access. And then our live cell pause is used during the comparison of positions to calculate our quote unquote interpolated position. Then we have our voxel world position that I'm not 100% sure we use anywhere. We do as a fallback. Counter value and our current cell we go ahead and grab before we go through our loops. Then we're going to iterate over each axis in that first array we added, and then each of the 4 corners to check on that axis. Then we'll go ahead and set up our positions for each block we're looking at. So again, that's our local index plus the converted cell center from the array. You can see here it's taking in the IDX, which is the corner of the block, the axis we're on right now, and the corner run we're on right now. Our adjacent cell is that position plus our axis, again converted to the positive position. Then we've just got a basic density calculation. As I've said before, this is not quite where we want to change things if we want to make this truer to dual contouring, but it's pretty close. If we were to use actual noise values here, we would get a much better looking mesh than we have right now. But I don't want that. I like low poly, so we're just going to leave it as if the block is solid, then it's got a density of 1. If not, it's air, 0. Then our normal calculation is going to be our adjacent cell density minus our root cell density. So the corner plus cell center minus axis. And then we need to invert that times which axis we're checking against to get the correct orientation on it. Then if our densities don't match, we'll go ahead and interpolate our position from that. So we're going to find the live cell pause as whichever one of the cells is actually active, and our adjacent cell pause as which one's not active for the sake of interpolating our position. And then we'll add it to our position like this. It's a weird little bit of math, but it works. Increment our counter so we can divide it down and get a more normalized position toward the end here. If our counter value never gets ticked, then this is just going to be a block. So we'll set that V world position, set our counter value to 1, get rid of that because that's not useful because of this little piece of code here. Then we'll divide our normal and our position by the counter. So that's it. That is our contouring method, and what did I say? It's really not that bad. Then we're going to move down to our main function here. We're going to add an array face norms times 4 and remove face UVs because that was a mistake to have there in the first place. It's not necessary. And we're going to change our color line. The only thing that's changing here is the R value here. So if we have that use textures toggle on, then we just want to make our R value our block ID -1 divided by 100. So if our block ID is 1, it'll be 0.001, I want to say. And then if we're not using textures, we'll just set it to our color. And then here's where we're going to get a little bit more complex or a little more weird. We're going to set up a local array of that shared vert struct we set up times 8, 1 for each of the vertices, and set it all to false. Make sure it's not being counted at all or it will mess up the method. So we're going to go ahead and add right here, and if not shared vertices, then we'll run that old code we had here more or less. There is a small change to it, but what that change is going to be is just going to be right here. And we're going to take this out entirely. It's not used anymore. So all we're doing here is calling our calculate contour method that we added above, giving it our index position for our block, the face vertices that we can output to, the face norms that we can output to, the actual vertex coordinate, and our vertex index, the IDX as I've had it named. And then we'll add our chunk position into that so our mesh gets moved wherever the chunk is. And then last but not least for this one, we're just going to replace our face UVs with voxel UVs and indexing into it with that voxel tries index. Then down here, we're going to add our shared vertex implementation. I think I have one too many. No, it just didn't auto format. Excuse me while I do that real quick. All right. So for this method, each time we have a solid face, we're going to increment our try count by 6 because there's 6 triangle indices per quad face. That doesn't change. And then we're going to do a loop over 6 and get our index for IK. So that'll be the vertice index. And if we don't have that point set yet in our array, we'll add 1 to the counter for our vert count. We'll calculate our contour with voxel vertices at that IDX, pass in the IDX. Then we'll set shared verts with this index to our vert count that was incremented up here and set it to true. Our B and A for our color gets set to our voxel UVs, same as before. And then we'll add our vertex buffer, normal buffer, and color buffer just like before as well. Once we have this shared vertice calculated, one way or another, if it's pre-calculated or we do it here, we'll add that as our index for the triangle. And that is it. So in theory, we can go ahead and come back over here. And I do have an error. It looks like I forgot to bring one array over for our voxel values. Let me put this up here where it makes more sense. This, just like all these other arrays, is just a way to index into our voxel vertice from a triangle index. So face 0, triangle corner 2 will be pulling out vertice 1. That's what we want to use. Okay, now that we've got this done, we are going to go ahead and pop over to our container file, which I'm actually, before we even start working on, I'm going to rename to chunk because I haven't started at all on the reason I named it container, which would be a voxel object editor. I'm going to do this by matching case just so any actual class calls are replaced with a new class call. And then we're going to replace the lowercase separately. And then we're going to go ahead and save all the changed files, pop back here. And we'll rename our container to chunk. Make sure we didn't just generate ourselves some new errors. Nope, we are good. So now we are also going to be removing our mesh data from within the chunk, and we're going to be putting it in an object pool within World Manager. So I'm going to go ahead and take that out, as well as noise buffer. That should not be here. Clear this stuff up real quick. And we're going to go on down to line 44, right about here. And we're going to call World Manager instance get mesh data because we'll be setting up that pool here in a minute. And then within our mesh data, we're going to be reinitializing our vertices, colors, normals, and indices. I had originally not wanted to do this, but it dropped me down to 1.7 gig of RAM from 12 to render 64 by 64 chunks, so I'm going to take it. And then our index buffer, we're going to go ahead and get our data from that first position in the array, and we'll set it off of that as well. And then if and only if we have shared vertices set in our world settings, we want to go ahead and pull our normal data into our norms array, hit caps lock in the middle of typing that. That's why I don't live code, in case you didn't know. Then, and again, if and only if we have shared vertices, we're going to go ahead and set our normals based off the normals that we calculated in our contouring. If not shared vertices, we want to recalculate our normals so we get that low poly look. And then at the bottom here, we'll go ahead and throw in a clear and requeue mesh for mesh data. Yep, clear and requeue our mesh data. Then at line 89, we're going to add our setting our normals to null. This is going to be renamed to colors because it makes more sense than having it as color, you know. Just a flat out struct name doesn't really make sense. We'll go ahead and add our norms array, pull out all this initialization that happens here, and add a function instead of our clear data called clear arrays. All that's going to do is null out all of our arrays so GC can pick it up and clean our mess up. I know I still have a lot of errors here, but they should take that out. They should get cleaned up when we finish with our world manager. So we're going to head over here now. And right below voxel colors, we're going to add a new line for voxel texture array. And we're going to also add a mesh data pool, which I forgot to pull out of our chunk. Can't be within that class if I want to access it elsewhere. All right, so we'll have two mesh data pool objects, one for our actual free objects and one just to hold all of them so we can dispose of them at the end of the run. Then we're going to change our initialize to use that max chunks to process per frame and add in a little function here that if our current shader on our material contains text and the voxel textures dot length is greater than 0, we want to go ahead and assign the material texture to be a texture 2D array that we're going to generate. And this is not going to be correct. This is going to be generate texture array, which is a function we'll be adding here shortly. But first we need to finish up with our mesh data pools. So the next thing we're doing for that is just adding a little for loop to generate our mesh data, same as every other pool I've made in here. Probably not the most efficient way to do it for some reason, but is what I do, so I'm keeping it in. So we've got our get mesh data. If the pool has any available, we'll dequeue it, return it. If not, we'll generate a new one and return that. Generate for our mesh data is very easy. It's just mesh data, new mesh data, initialize, and then enqueue it if we want to, and then return it. Then we've got a clear and requeue mesh data. All it does is null out the arrays, as I said before, and queue the mesh data back into the pool. Second to last down here, we're going to add a function. Where did that end if come from? Oh, okay. We're going to add a function called generate texture array. This is what will be used to generate that text 2D array that we'll be passing into our shader to handle, you know, selecting a texture and texturing our actual terrain. It's pretty simple. All it does is get the information from the first texture in the array and then pretty much just iterates over each texture and copy textures it into a array. Pretty simple. This does mean that your textures all have to be the same width and height, as well as format. You want bitmap generation disabled on them. For some reason, the copy texture does not appreciate having bitmaps. And then down here in world settings, we're going to add our 2 new bools. And then we'll be heading on over to Compute Manager for the last couple changes. In Compute Manager, right where we have this voxel color conversion that we were doing, we're going to make an if statement. And all it's going to do is if we're using textures, instead of copying our color information and converting it to a single float, we're just going to set it to 0 and pass in the smoothness and metallic that our voxel textures will be providing. And then we're going to set our bools for our voxel shader for shared vertices and use textures. And we will also pass in our normal buffer. And then we're going to head on down to our actual mesh buffer, add in said normal buffer so we can actually pass it in. And the initialization for our buffer is actually going to be slightly different, because if we're doing a non-shared vertices configuration, we don't want any normals to be generated. We're going to set it to 1 just so that it's set. But if we're doing shared vertices, we actually use less overall vertices, so we can divide what we would have used by 3, and if not, we'll keep the number we've been using previously. And then we'll go ahead and, how much do I have here? We'll put that in here, so we'll just be initializing our normal buffer and then disposing of our normal buffer. And then the only other thing I believe we need to do, I could be wrong because it's me, and let's be honest, I'm probably wrong, is make our voxel texture script, open it up, and this is all it's going to be. It's just going to be a texture 2D, smoothness and metallic variable. So this is all it's going to be. It's going to have a texture 2D, our smoothness and metallic variables. And now, where are we at with this? Oh, right, we renamed colors, or color to colors, and didn't change it anywhere. Let me do that real quick. Make this mesh data.mesh. And you actually aren't going to do this. I see, I made a mistake in making my little configuration here. Mesh is actually going to be housed within our chunk. So when we call clear data, we're also going to call destroy mesh. For that, we're going to do mesh dot clear destroy mesh, and then set our mesh reference to null. Sorry, I can't type. I'm having to reach around my microphone right now. It's not making it any easier than normal. Then we'll go ahead and delete mesh data.mesh and replace it with just mesh. And then we'll go ahead and run it, see if we have any errors here. We do have one more error. Looks like we didn't initialize our mesh data. Should be right here. So we'll just do mesh data pool equals new q, and then all mesh data equals new list. All right, let's see if that fixes it. All right, and look at it go. We have our low poly generated mesh, lightly contoured, and this is what everybody's been waiting for. Unfortunately, we do have one more thing to cover in this video, and I'm not looking forward to making it, so you're going to have to bear with me here. We're going to make a new shader, lit shader graph, call it Voxel Texture, and it's not a very complex shader, but I don't like making shaders at all. What we're going to do is we're going to take our vertex color and split it. We're going to create a new node called multiply. It's going to take in R, multiply that times 100. Just drop this up here somewhere. We're going to create a UV. Oh, sorry, excuse me. We're going to create a tiling and offset node as well. And then we're going to take a vector 2, pass in our B and A colors, because that is our UVs. Bring this up here. And then we're going to create a custom function node, which I'm going to go steal from vertex colors. And this is the node, if you don't remember, that unpacks our G value into metallic and smoothness. So we're going to change that to string, unpack floats. This is going to take a float inputs and then have two outputs, one X and one Y. We'll pass our B value into that and then run that into our metallic and smoothness nodes. And then we need to add a new property for texture 2D array. We're going to rename this to, what is it called? All right, so we will rename our reference here to underscore texture array. And just for consistency's sake, we'll name it texture array. Drop this up here. And then we'll make a texture 2D sample node. This will take in our texture array, our index from our multiplication node, and then our UVs. And then let me just slide all this over a little bit here. And then we'll pass that into our base color, and that should do it. We'll come back over here to our world manager, go to our voxel colors, set it to 2. And, you know, it helps if I grab textures, right? So let me do that real quick. We're gonna just put this here and drag and drop these in here. These are just textures I've collected from Google searches and, you know, probably not textures I should be using in an asset to any extent, but it is what it is for the moment. I'm not selling it. This is just a tutorial. We'll set our smoothness on our grass to 0.5, metallic to 0.1, and then invert that more or less for our rock. Then we want to go ahead and just verify that our grass leaves and rock textures are both max size at 256, high quality compression to make sure that matches, read write enabled, and no bitmaps being generated. Then we'll go ahead and toggle on use textures, and we should, if I did anything right, no. What did I mess up here? We are trying to use textures. We have, you know what helps is, it helps if you actually assign your, you assign the correct shader. So we'll rerun that. And our texture 2D array is not being copied to it. So what did I do wrong here? We're definitely trying to use it. Right? No, we're not. Try that with a capital T. All right, let's see if we're good now. There we go. That looks correct. And voila. Now we have textured, contoured terrain. And I know this is what everybody has been waiting for. And in the next video, I'll show you a preview here in a second. If you're wondering why I got this error, it's because I was moving before it finished generating all the chunks. It doesn't like that very much. So let's go over to part 7, or what's going to be a preview for part 7, and take a look. So the next part will be generating voxel foliage, like our little tree, our rock, or a bush here. And that'll be it. But it is a pretty tough process. It took me a while to get everything working for because, let's see if I can find something. No, that tree is good. This right here, being able to generate a tree in 1, 2, 3, and 4 different chunks, where the root is in only 1, was kind of a pain, but it will also set up our baseline for when we add water, which I'll likely be looking at in part 8 or 9. And it'll also be the basis for our actual save load system that we'll be getting to eventually. Thank you everybody for joining me for today's video. Hopefully everything made sense. If it doesn't, and you need some help, or you just want to come hang out, there's a link to my Discord channel in the video description, so feel free to go check that out, come hang out. There's also a link to my Patreon, as I mentioned in the last video. You don't have to go subscribe to that. It helped me out a little bit and let me know that you really like the videos, but I don't expect anyone to do that just yet. Thank you everybody for watching. As always, the source will be up on GitHub after this video comes out. And I will see you guys in the next video.